That's really an awesome lineup. Thank you very much, Kasam, once again. And with that, I would like to start with the topic for today of mine. I am here going to speak a lot about Azure Stream Analytics with an architectural discussion. So it's pretty much simple. Like we are going to discuss on how the data streaming solutions can be managed using Azure Stream Analytics. And I'm here, Feroz Khan, a quite long name, Abdul Rasheed Feroz Khan. I'm the founder and director of CodeSizzler, a Microsoft partner on learning, consulting, and on migrations. We operate both at India and UAE regions. And I'm a Microsoft MVP on Azure as well, holding the credit for probably like last 5 years. And I'm a MCT as well, a Microsoft certified trainer, handling Azure, Office 365, and Azure Data Platform Solutions certification trainings. I have an overall 8 years of experience as a cloud consultant on migrating the workloads from on-premise to the cloud environment and setting up hybrid clouds, setting up IoT solutions, setting up data solutions, etc. So with this, I would like to start for today. This next 45 minutes is going to be on streaming solutions using Azure Stream Analytics. And the key takeaway would be on understanding the data streams, understanding how the event processing works, and a demo on processing the events using Azure Stream Analytics. The very first question that sticks into the mind of why we need a stream analytics environment. You should have seen that today more data is generated from a variety of connected devices and sensors that we have. The way that you drive the car is almost like connected with sensors today, right? You have sensors like it calculates your torque, it calculates your TCS, right? Your control system of your car, your RPM that you have, the engine heat that it gets generated. Okay, so the sensors are almost like effective on whatever the devices that we use today or whatever the environment that we stick today. The traffic signal systems, having an IoT system, right? So these devices are connected and it transforms the data to various endpoints. Transforming this data is not just like storing it, but it also takes some actionable insights in real time, which we call it as operation necessity for the solutions. So here we get this service into picture, the Azure Stream Analytics. Azure Stream Analytics integrates all our environment. You go with Internet of Things devices and applications with a streaming analytics engine to gain insights with streaming data in real time. So consider that there are like, let's consider any company, right? Let's consider CodeSizzler as one company which has gained more confidence with Azure, and you can have a complete architecture to be laid with input and output of ingest data and generating the reports using the data that we have. It's not just about the reports, but also you can go ahead, you can build your stream solutions, which will be an actionable way that you're going to connect the architecture. So here we go on understanding the data streams. Just in the context of analytics, the data streams are event data which is generated by sensors or other sources that can be analyzed by another technology. Analyzing a data stream is typically done to measure the state change of a component or to capture the information which is said to be an area of interest. The intent of this data stream is to make sense that we continuously analyze the data to detect the issues and understand or respond to them. You can also understand the component or system behavior under various conditions to just go across with fueling further enhancements of the said components of the system. You can even trigger the specific actions when certain thresholds are identified on your data streaming solutions. In today's world, data streams are like ambitious. You have abundant of data. The companies can have the hardness, the latent knowledge in data streaming to provide efficiencies and further innovations as well. I have just marked some 4 examples where we use data streaming a lot. A stock market trend, monitoring the data of water pipelines, right, and the electrical transmissions and distribution by some utility companies like Johnson Controls, and mechanical component health monitoring data in automotive and automobile industries, and having your monitoring data from industrial and manufacturing equipments, having your satellite data to be censored, having the space industries, having the satellite data to be censored across, health monitoring system where the patient health monitoring data can be taken into insights by healthcare industries. So these are some examples where we can use data streams. So data stream is not like it's just like one stop. It also goes enhances the solution. Furthermore, discussing the technologies with AI. So you connect sentiment analysis, collect the data streaming solutions, do the social media posts to be analyzed using sentiment analysis API. The next goes here on understanding the event processing. The process of consuming data streams is on analyzing them and deriving actionable insights out of them, which is called as event processing. An event processing pipeline has three distinct components. One is said to be event producer, the next is event processor, and finally we have the event consumer. Event producer is where it includes sensors or process that generates the data continuously, like your heart rate monitor or a highway of, let's say, fast tag that we have in India. The next comes event processor, an engine to consume event data streams and derive the insights from what the data has been ingested across. Depending on the problem space, the event process will either process one incoming event at a time, like your heart rate monitor, or process multiple events at a time, like let's say a traffic signal system using Azure Stream Analytics. The next comes event consumer, an application that consumes the data and takes specific actions based on the insights is where we go with event consumer. The examples of event consumer can be like generating alerts, generating dashboards on Power BI, or even like sending data to another event processing engine. Here is about processing events, the step-by-step execution with Azure Stream Analytics. The Microsoft Azure Stream Analytics is an event processing engine which enables on consumption and analysis of high volumes of streaming data generated by the sensors, devices, or the applications. You can go with Stream Analytics process with the data in real time, and a typical event processing pipeline will be built on top of the Stream Analytics, consisting of the four components like source, ingestion, analytics engine, and the destination. So the event producer, that is, the event producer is nothing but the source. Any application, system, or sensor that continuously produces the event data is said to be the event producer. So here what happens is that you just go to the event producer part. You will have the sensors that tracks the flow of water in a utility pipe or a vehicle that crosses a traffic signal, okay? Or let's say the tweets that are posted by, any common people using hashtag. So those are the data which can be collected. It can be from sensor or it can be from system or even using applications. And then we have this event ingestion system. This takes the data from the source system or application to pass it onto an analytics engine. You will be having Azure Event Hubs or IoT Hub, or let's say even a blob storage, which can have serving as the ingestion system. You will be then having the Stream Analytics engine, where compute is run over the incoming streams of data and the insights are extracted using it. Azure Stream Analytics will expose the Stream Analytics query language. We call it as SAQL, which is said to be a subset from transactional SQL language. So this is tailored to perform computations over streaming the data. The engine supports windowing your functions that are fundamental to stream processing and are implemented by using your SAQL. You will then have the event consumer, a destination of the output from the Stream Analytics engine, and the target can be storage such as like your Azure Data Lake, or let's say a Cosmos DB, SQL database, or even a blob storage. For reports, we use Power BI, which comes with a dashboard environment. Here is about transforming data using Azure Stream Analytics. So until now, we have been discussing about the basic terminologies and the step-by-step execution of how the Stream Analytics can be used. And here is about transforming data using the same Stream Analytics engine. Here in this transforming data, you will make sense about exploring the Stream Analytics workflow and creating a job, setting up the job input, and writing a transformation query and starting the job as well. So this will be like a short demo which I'm going to show you. Let's start with understanding the Stream Analytics workflow. In Azure Stream Analytics, a job is said to be a unit of execution. A Stream Analytics job will have the pipeline, which consists of three parts: an input, which is said to be a source that provides the source of a data stream, and a transformation query that acts on the input. Let's say, for example, a transformation query which could aggregate the data, and finally, an output that identifies the destination of the transformed data. End of the day, your overall architecture for a solution will be like this. You'll be having IoT devices or IoT edge devices which can do the device management. It can be communicated using the cloud data gateway, which whitelists the device connectivity to transfer the data. And here the data transformation is done using function app. It can store the data in Cosmos DB, and you're going to stream the data carrying from various IoT devices towards a stream processing. So input is set to be from IoT hub, and here you're going to store the output. Once after the data gets processed, you're going to store the output on a Cosmos DB in a warm path, and for the cold path, you're going to use a blob storage. At the other end, you can also generate outputs towards Power BI on the dashboard, which can help you on the reporting. So this is all like the overall execution of how the Stream Analytics can be used in a real-time architecture. With this, I'll be moving on to a demo to make sense about how the data streaming solutions can be built using Stream Analytics. So the implementation plan is that we are going to work on we discussed the architecture and we are going to implement a job. We are going to create a job. We will set up a Stream Analytics job input and an output as well. And they will be writing a transformation query starting with the Stream Analytics job. Let me go up here. The very basic thing that you need is set to be Azure portal. So let's start holding on with the Azure portal environment. Excuse me. Oops, one moment. Okay, here we go. So let me log into the Azure portal. So here we can go up on creating a Stream Analytics job first. So the very first step that you need to do here is that, let me open up a notepad. I need to create an Azure Stream Analytics service. So let's go to the portal. I'll say create a resource and we can set up a Stream Analytics job. Let me click on create. I will give up a name here. So probably let me name it as simple transformer. And let me put up a resource group here. I'll say Dear Azure AI resource group. I'm going to deploy it on a data center region, which is set to be Southeast Asia. And the hosting environment is set to be on cloud. So cloud in the sense, the connected IoT devices or any sensors will be there on the cloud environment. Perhaps when I say edge, it's set to be at on-premise. So let's go to the cloud and streaming units. It's going to be a very minimal layer. So I will say 1 and let's get this to be created. So here is the Stream Analytics job. As I said, you need to put up an input and an output terminal, and then you need to write the query on SAQL. So when you say inputs, the job inputs, let's say add a stream input, you'll find three things there. One is event hub, the second one is IoT hub, and finally you have blob storage or the data lake. So event hub consumes your live streaming data from applications which will be having low latency and a high throughput as well. And IoT hub is that it consumes live streaming events from IoT devices like Raspberry Pi or any simulator devices. This service, IoT Hub, will enable bidirectional communication scenarios where the commands can be sent back to the IoT devices to trigger or to take specific actions based on analyzing streams that they send to the service. And finally, you have the blob storage, which is used as the input source to consume files which is persisted in the blob storage. So here, let me create an input source, name it as a blob storage. And here we are going to call that. So before doing this, I need a blob storage, a storage account to be created. So let me create a blob storage now. Let's go to the resource group and I'll create a blob storage here. I'm a bit fast on creating it as we have 45 minutes and you can look for the recording to make sense more. Okay. Let me click on create. So let's say courses for storage. Cool. Okay, here goes my storage account. And here inside the storage, I can create a blob, okay, a container and a blob. So let's name it here. I will just say it could be, let's say it will be in the name of some container name, okay, probably learn container something. Learn container and I'll create it. Now let's call this container on the blob storage part here as an input. So input, let's say stream input, right? And I'm going to select the blob storage that we have. Let's pick it up here, saying container, use existing. Okay, let's try refreshing it once again. Wait. Stream input, blob storage. So let's connect with the connection string, and yeah, we can go with the path pattern to provide the input. Okay, it can have a folder for it. So let's say input, and from there on, it's going to create a date, format, all those things, and we can, oops, yeah, and we can try creating it. Okay, so let's say save. So now you can find data input for the stream analytics job is getting added. Okay, so here the connection is established successfully, and on the job topologies, again, you click on the inputs, you can find it here, just like this, no, stream input, which has been connected over here. If you want to delete, you can also try taking up action over here. Now let's configure an output for the same. Okay, so you just go up, click on the outputs, and create an output pointer here. Say add, and we can go up on adding an output, which is said to be for Stream Analytics on the storage account. So let me say the output will be again a storage account. I will put up a new storage account for this. Okay. Either you can create a new storage account or you can even connect with the same storage account. Either of these things can work. Okay. But then let's maintain a separate container alone. So here let's put up a container path. I'll say container. And the name will be output container. Let's click on create to get it done. And there, no, you can go up here. You can say the output is going to be written on a blob storage once again. I'll say output container. Makes sense. You can put up your output name over here, anything. Okay, your output array's name over here. And for storage, let's select the storage from the subscription that we have. And this time it's going to be on the output container that it's going to write the data. And yeah, that's it. Path pattern, just same like input, you can say output. And click on save to get it created. So here we are with the testing connections on the input and output which has been done. You can now try writing transformation queries using this query explorer. Say an Azure Stream Analytics query will transform an input data stream and it will produce an output as well. So the queries are written in a language like SQL that's a subset of the Transact SQL language that we have. Here we are going to transform the input data in a very simplest way to demonstrate the transformation query capabilities that can work with this Stream Analytics engine. You can here find we have a stream input and we also have an output container which we created. You can create a sample input file. Let me say I will go up with the sample input file to be created. This is going to be my sample input file. City, I'm giving up some name and coordinates with latitude and longitude and census with the population, region where it falls, etc. So let me save this. I will put it as input.json. So we have it here and we will try uploading this input file on the container. Okay. So go for this storage account, open the learn container and try uploading this file. So I'm here uploading it. There we go. Either you can upload it like this directly, or if you want to put it, see, in a real-time architecture, when you have a series of data, you need to maintain it on a structured folder. So you say upload and go to advanced. You can even create a folder and upload it. So you say upload to folder and let's name it as input slash, okay. Let me say 2021 1 and it's 16 Jan, right? So let's name it here. And now I can try uploading the block and the input file. Let's say upload. I hope you can make sense. Here we have the input, okay, and inside that we have a folder and we have the input JSON files which are available as well. Now let's go. We will write the output. Okay, so the output we need to maintain it on a folder. Let's go for the storage account, opening it on new tab again. I'll go to the storage account, containers, output container, and here let's create a new folder. Okay, you can put up like upload, and you can say that I need a new folder to be created. So we don't have that option here. Instead, what you can do is you just go to the storage explorer. See, we have storage explorer, no? Open this, go for blob containers, you have output container, and inside this you can create a folder now. So this is a virtual directory folder. You can name it here as output. I hope you can see this output container, and we have an output here. Now let's write the transformation query. Okay, you can say go here for the transformation queries. Okay, remove all these things. We can just say select, okay, city and the coordinates for it. So coordinates, latitude, and coordinates, longitude, and we are going to generate this data into, let's say, stream input, or okay, it's not stream input but stream output. So my output part is, let me check here. It's here available on my inter. Go to outputs. So it's on output container. So you say into output container. Okay, and from, it's gonna be stream input. So say stream input. You can even see it here. See over here. So here we are mentioning the query that it has to represent the cities that we have. You can just say save and test the query as well. Before you run a job, it's said to be a good idea to test the query to make sure that it does what you want. So here in Azure portal under Stream Analytics job, you can go with the job topology, and you can run the test as well. So let's say test query. There's no data from stream input. Please make sure that the input source as data and try again. Okay, we need to add some input, no? It's there, isn't it? Over here in the container. It's there on learn container input. We have the data. Select city, coordinates with latitude and longitude. Enter the container from stream input. Let me check. JSON. Just give me a moment. Let me check the input, stream input part. Inputs, we have stream input, learn container, obviously we have it there. Input.json. Okay. The problem is that we have mentioned it as a private, isn't it? Let's go up here. The container which we create here should be on with the public access. So let me remove it. Give me a moment. Go for the storage account. And the container which we create here, learn container, and the folder node, this should be with the public level of access. So let's say container, anonymous people can read it as well. And same for private output as well. Into, let's say, output container, and it's set to be on stream input. Well, okay, can you make sense here? This is the data that we have. Let's say save query, and here you have the data which is set to be retrieving with latitude and longitude, and the city is listed out here as well. So this is how you can process the input. You can get the output files which should be available, and you can process the data not just on the storage account but also from let's say it can be from your environments like IoT hub, or you can even go with event hub, process data, anything. And to monitor these things, you just go to the overview. You can start running these queries. You say start, and you can start running it. Or if you want to put it on a customized start time, you can mention it over here. So you say start, and the Stream Analytics engine can start running up the data. Once when this runs the job, you can find the monitoring status here. Let me show it here. See, in monitoring, you'll be getting a visualized reports. Well, yeah, start streaming job. Okay, it should take some time to show your data to be monitored over here. I'm clicking on the monitoring, and you can find the metrics. It can pull out the charts over here as well. So that's about the Stream Analytics, building the data streaming solutions. Any questions? Feel free to let me know if you have any sort of questions. So the streaming job has been started successfully, and you can find the reports here. Okay, as it runs, it would take some time to see your monitoring and the resource utilization. Cool. So with that, you can just let me know if you have any sort of questions. We have been discussing about Stream Analytics, and we are done with the demo. What type of sensor data can be consumed? We saw JSON. Any other formats? Your data should be always in sort of like JSON or CSV, something like that. Even the data which gets generated in a CSV file, you put it on a IoT hub or a blob storage, those things can also be processed. Okay.
Thank you all for joining. Thank you, Feroz, for this wonderful session.
Thanks, Kasam. Thank you so much for your time as well on hosting this wonderful event and lining up the rockstar speakers over here. And last but not the least, thank you so much, attendees, for having your time on this Global AI Bootcamp. Have a happy learning, and I would like to see you on the social chats and communities having your questions to be answered. Thank you very much.
Thank you.